Hey everybody, we are talking about inverse functions today. Let's get started. So in inverse functions, we say that if there's some function f of x and some function g of x, and we know that f of g of x equals x, and backwards, g of f of x equals x, then we say f and g, those two functions, are inverses of each other. We also know something is one-to-one if the value, if a and b are in the domain that f of a equals the function of some value b, then we know that a equals b. Okay, and we've already talked about the horizontal line test, but it's also a test to see if a function is one-to-one. So just like we use the vertical line test to test to see if it's a function, the horizontal line test is used to see if it's one-to-one. Basically, if we have a function, let's say, I don't know, like this. If we draw a horizontal line through it and it only hits one time, then it is one-to-one. So let's talk about inverse functions for a little bit. For a function that's defined by a set of ordered pairs to form the inverse function, we basically switch x and y. So let's say, for example, if f of x is the set of 1, 2, and 3, 4, then the inverse function of those two will be the set of, instead of 1, 2, it's going to be the opposite, which is 2, 1, and 4, 3, where we switch the x and the y. Okay, so for a function where f is the function and its inverse is f of, we say -1 or inverse f, the domain of x is the same as the range of the inverse function, and the range of f is equal to the domain of the inverse function. And to verify that these two are inverses of each other, then we know that if I take the composition of f of g of x and it equals x, and g of f of x equals x, then they're both inverses of each other. So let's do example number 1. So if f of x equals 2x minus 3 and g of x is x plus 3 over 2, let's determine if they're inverses of each other. So I'm going to look to see if f of g of x equals x. So f of g of x. Let's go ahead and put g of x. Remember, we write the outside first, so 2x minus 3. But instead of x, remember, we're going to replace that with g of x. So g of x is really x plus 3 over 2. Let's simplify that. I know 2 divided by 2 is gone, so I get x plus 3 minus 3. Well, I know minus 3 and minus 3 and negative 3 is just x. So far, f of g of x equals x. That's good. So let's look at g of f of x. So we write the outside function first. So outside function is x plus 3 over 2. And what do we put in for x is the f of x. So we're going to stick that in right here. So f of x is really 2x minus 3. Let's simplify. And here I know 2x minus 3 plus 3, these cancel. We're left with 2x over 2, and that just equals x. So both of these both equal x. So we say yes, f and g are inverses of each other. All right, let's do the next one. It says the graph of an inverse function. So if the point AB lies on the graph of f, then the point B, comma A lies on the graph of f of the inverse, and vice versa. So the graph of the inverse of f is a reflection of the graph in the line, which is x equals y. So that just means This is the graph f equals y, or y equals x, which is a linear equation. So the inverses of each other just flip over this line. Okay, let's talk about the existence of an inverse function. Okay, so if the function is 1 to 1, that means that no two elements in the domain of the function correspond to the same element. In the range. This sounds a lot like a function that you can't have two repeating x's. Also, a function f has inverse f of x if and only if it's 1 to 1. And it passes the horizontal line test. To tell whether a function is 1 to 1 from a graph, we use the horizontal line test to check that it intersects only once. So does this graph at the right have an inverse function? So let's do a horizontal line test. Let's draw any horizontal line here. It hits 1, 2, 3 times. So this does not pass the horizontal line test. So does it have an inverse function? The answer is no. It doesn't pass the horizontal line test. So here's the steps to finding an inverse function, okay? So first we're going to use the horizontal line test to see if it even has a function. If it does pass, then we're going to say we're going to replace, when we see f of x, we're going to replace it with a y, because we know y is f of x, but we are going to replace it. The second one is we're going to now switch x for y. And then you're going to solve for y by itself, and then you're going to replace back y for the inverse of the function. Okay, so let's use those steps and see if it exists. So let's look at f of x equals 4x minus 5. We know 4x minus 5 looks like something like this. Does that pass the horizontal line test? It does. So if I draw a horizontal line here, it only passes one time. So we use the horizontal line test, check. Now we can move on. Now we're going to write this, and we're going to say f of x is now y. So we say y equals 4x minus 5. Step 2, we're going to switch x for y. So instead of y, I'm writing x. Instead of x, I'm writing y. Now I'm going to solve for y and get it by itself. So I'm going to add the 5 to both sides, and I get 4y equals x plus 5. Now I'm going to divide both sides by 4, and I get y equals x plus 5 over 4. Last step, replace the y for the inverse of f. So really the inverse is x plus 5 over 4. And I could rewrite that as the inverse of f of x is x plus 5 over 4, and that's my inverse equation. That's it for today.